This section will go over scatter plots. Scatter plots are a graph with points plotted to show a relationship between two sets of data. So if you notice here, we have a graph, but we just have numbers. So we have body mass index and we have hours. So we're comparing active hours per week to body mass index. We're going to see if there is a correlation between these two factors. And a correlation is simply a relationship between the two data sets. So if we're seeing if there's a correlation between these body mass index and hours, we're just seeing, is there a trend that's going to occur? If there is a trend, then we can say that there is a line of best fit. It's just a straight line that comes closest to the points on a scatter plot. So in our first example, I went ahead and plotted these points. The first point was 10 active hours per week and a body mass index of 16. So I went to 10 for hours, and I went up until I went to 16, and that's this point right here. Okay, so basically we do that for each one. We plot all the points. We do not connect any lines, and then we see, is there a trend? Is there something that we can see from this, the grouping of this data? If you notice, for the most part, as we get more hours, our body mass index decreases. If this type of trend occurs, we call this a negative trend or a negative correlation. One thing to keep in mind is that correlation goes with slope of the best fit line. So if we look at these slopes, this very first one, the slope goes up. It is positive. Notice how close all the points are to this line. Since those points are so close together, we call that a strong correlation. And since the slope of the line is positive, it's going up, that means it's a strong positive. Okay, the next one, the line's still going up, so it's still positive, and the points aren't quite as close to the line, so it's going to be a weak positive. If we jump over one, we'll skip one. This one is going down, the line is. It's negative. And it's not as strong as this one. The points aren't nearly as close to that line, so we're going to call it a weak negative. And by using that information, we can tell if the last one is strong negative. Let's go back to the one that we skipped. These dots are just kind of scattered everywhere. Okay, we can't really tell if there's a trend or a correlation going on here. We call this no correlation or no trend. Let's look at example A. It says the number of hours a plane is in flight and the number of miles flown. If we were to plot these two numbers against each other, we would say that the more miles that are flown, so as we move from left to right, the more hours we're going to be in the air. So this is going to be moving in this direction. It is going to be a positive correlation. B, the number of hours in a flight and the number of passengers. We have to ask ourselves, is there a trend or a correlation, a relationship between these? There could be 4 people on a short flight. There could be 4 people on a long flight. There could be 200 people on a short flight, 200 on a long flight. These numbers could be all over the place. So this one is no correlation. We cannot tell anything just simply looking at these two data. And the last one, the number of hours in a flight and the number of gallons of fuel remaining. Again, we ask ourselves, can we predict anything from this? We're going to say that the longer this flight occurs, so the longer the hours as we move left to right, we're probably going to start off with a lot of fuel, and we're going to end up, as we move with more and more hours in flight, that's going to decrease. So that's going to be a negative. So if both increase or both decrease, then it's positive. If one increases while the other decreases, it's going to be a negative. They're going to work kind of against each other. Thank you for viewing these, and I will see you on Wednesday. Bring any questions.